Hello, dear students. Welcome to a new session. Today we'll be talking about central angles and measuring arcs. As you can see in the opposite figure, the two sides of sector AMB divide the circle M into two arcs. The red arc, which is the minor arc AB, and we can write it as arc AB. The major arc ACB, which is denoted by arc ACB. What is a central angle? The central angle, it's the angle whose vertex is the center of the circle and its two sides are radii in the circle. So as you can see here, angle AMB is called a central angle. So arc AB is opposite to the central angle AMB, and arc ACB is opposite to the central reflective angle AMB. How can we find the measure of the arc? The measure of the arc is the measure of the central angle opposite to this arc. Let's move to examples. Let's go to example 1. In this example 1, in the opposite figure, AB is a diameter in the circle M. MC is perpendicular to AB. And measure of angle AMD is equal to 60 degrees. And it's also given that arc AB is opposite to the central angle AMB. Then, as you can see, if the question is asking you to find the measure of angle AB, exactly, it will be the measure of angle AMD, which is given as, yes, excellent, 60 degrees. Let's move on to the second one. The question is asking you to find the measure of arc CB. Arc CB is opposite to the measure of angle CMB. Yes, exactly. They both have the same measure. So the measure of arc CB is also equal to, wow, 90 degrees. You guys are great. Number 3. The question is asking you to find the measure of arc DC. The measure of arc DC, where is the central angle opposite to it? It's the angle DMC. Yes. How can we find the measure of this arc? You will see that angle AMB is a straight angle that has a measure of 180 degrees. So it's 180 minus the sum of 90 and 60, which will be 30 degrees. Or you can also say that angle CMB is equal to angle CMA, because CMA is also a right angle, which is 90 degrees. So the measure of angle CMD is 90 minus 60, which is also 30 degrees. The last one, it says, find the measure of arc AB. As you can see that arc AB is a semicircle. The semicircle, its measure is 180 degrees. If you want to do it, the arc AB, its measure is the same as the angle AMB, which is a straight angle. Straight angle is also 180 degrees. Great job, guys. How to find the arc length? Arc length is a part of the circle's circumference and is proportional with its measure. So, the arc length is the measure of the arc divided by the measure of the circle multiplied by the circumference of the circle. Let's go and check an example together. In the opposite figure, M is a circle with radius length of 5 centimeters, where the measure of arc AB is 108 degrees. The question is asking you to find the length of arc AB and is telling us to use pi equals 3.14. So the solution, arc length, here's the rule. The measure of the arc, which is how many degrees? Yes, is 180 degrees. Divided by the measure of the circle, which is how many degrees? Wow, you guys are awesome. 360 degrees. And then you multiply it by the circumference of the circle, and its formula is 2 pi r. So it's 108 divided by 360 times 2 pi times the radius, which is 5. So the answer is 9.42 centimeters. Now let's move to corollary number 1. It says in the same circle or in congruent circles, if the measures of arcs are equal, then the length of the arcs are also equal, and conversely. So if you check here, if you have that the measure of arc AB is equal to the measure of arc CD, then automatically the length of arc AB is equal to the length of arc CD. And here's the conversely of it. And conversely, it says if the length of arc AB is equal to the length of arc CD, then automatically the measure of arc AB is equal to the measure of arc CD. So if the length of an arc is equal to the length of another arc, then the two measures of the two arcs are also equal. If the measure of one arc is equal to the measure of another arc, then automatically the length of this arc is also equal to the length of this arc. Another corollary, in the same circle or in congruent circles, if the measures of arcs are equal, then their chords are also equal in length, and conversely. Let's check it on the circle. Here, in this circle, the measure of arc AB is equal to the measure of arc CD. Then, the length of chord AB is also equal to the length of chord CD. The converse of it, if chord AB is equal to chord CD, then automatically the measure of arc AB is equal to the measure of arc CD. Is it okay? I think it's okay now. Let's move on to corollary number 3. If two parallel chords are drawn in a circle, then the measures of the two arcs between them are equal. As you can see in this circle, that AB is a chord and CD is another chord. These two chords are parallel to each other. Then the measure of arc AC is equal to the measure of arc BD. Now, let's go to the last corollary, which is corollary number 4. It says, if a chord is parallel to a tangent of the circle, then the measures of the two arcs between them are equal. As you can see here, chord AB is parallel to tangent CD. So, the measure of arc AC is equal to the measure of arc BC. How about we go and apply this in some examples? Let's go to the exercise. In the opposite figure, AB is the diameter of a circle. This circle is called circle M. Let's study the figure and complete the givens. The question here is asking you to find the value of x. As you can see here, that AB is the diameter of a circle. And we know that diameter of a circle, its arc is a semicircle, which is 180 degrees. So you're going to make 4x plus 3x plus 5 equals 180. Then x equals 25. Wow. Second one, if x equals 25, remember this very well as we're going to use it in any of the coming arcs. The question in number 2 is asking you to find the measure of arc AC. AC, where is the central angle opposite to AC? It's 2x, which is angle AMC. If x equals 25, so 2x equals 50 degrees. Question number 3. Find the measure of arc AD. So you go to arc AD. Where is the central angle opposite to arc AD? Yes, it's angle AMD. What's the measure of this angle? It's 4x. Then 4x. And what's the value of x? Yes, value of x is 25. So if you multiply 4 by 25, the answer is 100 degrees. Question number 4. The measure of arc BC. Again. Arc BC. Now, we don't have any label for the angle opposite to it, or the central angle opposite to it, which is angle BMC. But we know that the whole circle is 360 degrees. If you subtract angle DMB and angle DMA and angle AMC from the 360, you will see that angle BMC, which is the central angle opposite to arc BC, is 130 degrees. To get this, you need to substitute each x value you have by 25 that we got it in point number 1. Question 5. Find the measure of arc CAD. Take care of the letters because the letters are telling you the direction. CAD is 2x and 4x. If you add 2x plus 4x, it is 6x. And what's the value of x? It's 25. So 6 times 25 is? Yes, 150. So the measure of arc CAD is 150 degrees. Next one, the measure of arc CBD. CBD, yes. CBD is what? Is CB and then BD. CB, we got it in number 4, which is 130. And DB, we need to substitute x by 25. So it's 3 times 25 is 75 plus 1, it's 80. Then you combine them together, CB plus BD, so it's 80 plus 130, it's 210 degrees. Measure of arc ACD. ACD is the whole circle except AD, right? So it's 360 except AD that we got in point number 3, which is 100 degrees. So it's 360 minus 100 is 260 degrees. Last one, to find the measure of arc ADC. Measure of arc ADC is the whole circle except arc AC. Arc AC, we got it in point number 2, which is for 50. So arc ADC is 360 minus 50 is, wow, it's 310 degrees. Let's go to another exercise. In the opposite figure, M is a circle where CD is a tangent to the circle at C. AB and EF are two chords of the circle where AB is parallel to EF is parallel to CD. How to complete the following to prove that CE is equal to CF? Let's start by the givens. We know that AB is parallel to EF as given. Then, which two arcs are equal in measure? Good job. Arc AE, the measure of arc AE is equal to the measure of arc BF, which are the two arcs in between the two parallel lines. Another given that we're going to use, that tangent CD is parallel to arc AB. Then we have two arcs that their measures are equal. The two arcs are AC and BC. Excellent. So if we add the two sides of 1 and 2 together, you will see that the measure of arc EC is equal to the measure of arc of, wow, FC. Then automatically, as the question asking you to prove CE equals, yes, CF. By this part, we came to the end of our session today. Thank you very much and good luck.